Let's look at something called free rotation, which we experience every day of our lives. In the previous section, we spoke about rotations about a fixed axis. Okay, so what do we mean by that? We had an object here, and there was a bunch of forces acting on it, and we chose an axis about which we wanted to study the rotation. Okay, what about this guy? We chose this guy as our axis of rotation, and then we chose this point as our axis of rotation. But this was fixed. Okay? Let us now consider what happens when you simply throw an object and it rotates. You throw it through the air and it rotates. So for example, a frisbee, throw a frisbee. Or you take a pencil and you flick it and it moves away from you and rotates. You throw a frisbee and it rotates while it's moving through the air. Okay? The question is, about what point of or axis do freely rotating objects like the pencil and the frisbee rotate? So this is called free rotation, and we want to know about what axis do these objects rotate? Okay, so let us consider a picture again, and we'll consider this wrench. Okay, well, we call it a spanner. Okay, so you take the spanner and you rotate your wrist and you throw it up. So it's going up and it's rotating. So it's experiencing free rotation. Okay. And if we analyze, there's this dot on here, okay? If we analyze this white dot, we will see, let's rather just say, there is this dot, this point on this spanner, okay? And we call it this white dot. That if you analyze this position, as the spanner is moving up and rotating, then you can see the distance of this dot keeps decreasing and decreasing. Okay? And it also looks as if it's just moving straight up. So, what is this point? Well, we know this point is the center of mass. And our conclusion, okay, it says the white dot on the wrench is the center of mass of the wrench, of the spanner. Okay? And this is a marvelous conclusion here. It says, objects that are made to rotate without external constraints, meaning we don't fix, we don't choose the axis of rotation and say, you must rotate about that axis. No, in this case, we just allow the object to freely rotate about whatever axis it chooses. Okay, so objects that are made to rotate without external constraints always rotate about the center of mass. Okay, so this is actually quite marvelous. As we throw this guy up, we can see that its center of mass moves as though like you threw a tennis ball up. Okay, you threw a tennis ball straight up, it begins to have a negative acceleration. But at the same time, all particles on this object rotate about the center of mass. Okay? So it says, this shows how remarkably powerful the concept of center of mass is. It allows us to break down the complex motion of a freely rotating wrench into two separate parts. Translational motion of the center of mass. Okay? And rotational motion of the wrench about the center of mass. So we can break up the motion into these two components. Okay, so that is that for that section.